All right, let's check the sound. Looks good in OBS. Turn this preview off. Let's get the chat back. All right, real quick, I want to mention before the introduction, because I think I must have missed it yesterday, but thank you to Dizintiv, who followed on Twitch yesterday around the time that we were streaming last night. I don't know if that came in before I started or while the stream was running, but one way or another I missed it, so I wanted to thank that person. And let's do a quick intro. Let me pause this and get the chats back, and then we're ready here. All right, so hello everyone, my name is Tim. Go by foamyguy on Discord and GitHub, and we will be working on CircuitPython related things. So if you're new to the stream and you don't know what that is, head over to circuitpython.org. You can learn more here. This is basically a version of Python that runs on all of these little tiny computers, which is what all these different devices here are. These are called microcontrollers. They're essentially just a tiny computer that can control, I/O pins, like turn lights on and off, make sounds come out of speakers, have sensors like temperature and humidity or acceleration. All of that sort of stuff you can hook up to these microcontrollers, and this is a way to write Python code that runs on these devices. And what is one of my favorite things about CircuitPython is that the device shows up as a thumb drive. So I have it opened up here in PyCharm, but if we look on my computer, we have this CircuitPy drive. This just shows up just like any other thumb drive or SD card would. And on that drive, there's a code.py file. You just edit that file, save it, and then once you save it, the device notices that it changed, and it will automatically kind of reset and run the latest version. So that's a real high-level intro to what CircuitPython is about, and that is the kind of stuff we'll be working on. If you want to get involved, if you do go to circuitpython.org, there's a contributing link at the top. This is going to take you to a page that lists all of the open pull requests, as well as all the open issues. Pull requests are a good place to get started because you can just look over the changes that someone else made. You can test it out if you have the hardware, or you can just look over the code and see if there's anything that jumps out to you as like maybe needs to be changed or improved, or if there's any misspellings or anything like that. There's kind of stuff for all levels of experience in reviewing these PRs. You can take a look even if you don't have a lot of experience. That's totally fine. Just take a look and let us know if you checked it out, or if you tried it on hardware, or if you found anything that you think might need to be done differently. So that's what the pull requests are about, and we are going to be reviewing a couple pull requests today. The other one that's listed here is open issues. This is a little bit more advanced. This is actually going to be, you finding an open issue, coming up with a solution for it, and then making your own pull request so that it can get, eventually merged into the library. So these ones are, probably going to be better if you have a little bit more experience, but there are some that are still relatively, easy. We have these ones that are good first issues. These ones especially are good for folks that don't have a lot of experience. And a lot of the ones we have right now are the missing type annotations. So these are basically just, looking at the library, looking at all the function calls in the library and determining what the types are supposed to be for the arguments and the returns, and then just filling those in to the code. So it doesn't require a whole lot of, foundational knowledge. You can kind of just look at the code and figure out what the types of things are supposed to be. Whether it's an int or a float or a string or some kind of object or, what have you. So those are a lot of the open issues right now. And I will say also, Hug Report, thank you to TechTrick on GitHub, who has been continuing to do a bunch of these type annotations as well. So thank you to them for working on so many of these. All right, so one other thing that I'll mention, if you do want to, kind of help the project along, but you don't necessarily want to get involved in the development, reviewing PRs and tackling issues. Another thing you can do is purchase hardware from Adafruit. This is their website, adafruit.com. They sell a bunch of the different microcontrollers, a bunch of the different sensors and breakouts and lights and sounds and buzzers and buttons and anything else you can imagine that you're able to plug into these microcontrollers. They sell all kinds of that stuff, and they are the folks that are providing the financial backing primarily for CircuitPython. So they pay the team that works on CircuitPython full time, the folks that actually work on the code and maintain the libraries and foster the community around the project. So they are very, very important in the project, of course. And so if you purchase your hardware from them, you are kind of indirectly supporting that CircuitPython project. So I always like to encourage folks to do that. And you can get some fun toys out of it if you purchase hardware. So the PRs I want to take a look at, that's what I'm going to start with today, is reviewing a couple PRs. One of them is in DisplayIOLayout. This is a update for the Cartesian widget, and it's basically allowing it to draw lines on the graph. Cartesian makes like a graph, a 2-axis graph, X and Y. It draws some little tick marks to measure, like to label the axes. And previously we were able to plot, I think, points inside of that, or maybe just a single point. I'm not actually super sure. But this person, SLight on GitHub, has made a new feature where we can actually plot lines on the Cartesian instead of just points. So we're going to take a look at that and do the review, and if it looks good, we'll get it merged up. One thing I do want to check on, so we're moving these widgets out to the CircuitPython organization, but I don't think that Cartesian is done yet. Oh, there is Cartesian over here, actually. Move max size. So we will ultimately want to take this update and get it over into this version of the repo, because it will eventually get removed from DisplayIOLayout. We're trying to cut the DisplayIOLayout library down to just layouts like grid layout or linear layout, or others that come along if we end up having any others. But it's meant, primarily meant for layouts rather than widgets. We ended up adding a bunch of widgets when we first created it. But later on, we decided we want to break those up and have individual libraries, and the CircuitPython organization is a good spot for those. So this will eventually get moved over, but we will go ahead and do the review here for now, and then we can still copy it over later, and again, eventually it'll get removed from this one. But that does exist over there, but we're going to stick to this one, and let's open up the repo. Okay. And I should PyPortal. I think my PyPortal is around here. Yep, there it is. Portal. Scooch this feather out of the way. PyPortal. Let's make sure we got the cord for it. Yep, it's falling up over, but can pull that back up. There we go. And I guess maybe this is gonna play something out of the speaker. Oh no, okay. Let's set it to a different code. So we're good there. And let's pull this back. All right. So we just want to get the code from the PR. Good way to do this is with the GitHub command line tool, GH PR list. We can see a list of all the PRs. We can see 62 is the one that's open currently. PR checkout, no, git GH PR checkout 62. This is going to pull the branch from the PR into our local copy of the repo here. So now our code is the code that's in the PR, basically. So let's take the library, DisplayIOLayout. Let's put it on the device. I'm going to delete my old one. Actually, it looks like I don't have it installed on the device right now. You know what, though? This did not change, right? This is the feather, and I have 2 devices connected now, actually. So let me unplug the Let me unplug the feather. So here's the PyPortal. This feather we were working on last night on EPROM memory. So I still had it plugged in from that. So I'm actually also going to unplug and replug the PyPortal so that it should show up as CircuitPy instead of CircuitPy1, and it should also show up as TTY ACM0 for a serial port. And looks like we already have serial open. Yeah, this is our PyPortal now, so we're good there. All right, make sure the camera's looking all right here. We're gonna do a bunch of this testing on the PyPortal, so can get it focused up a bit for that. A little better, right? And we'll hide this, and then, so we should have this on the device now, I think, right? I probably have it on this device. It just wasn't on the feather. Yeah, DisplayIOLayout. So we're going to delete that. That way it's gone completely. And then we're going to copy it in from, again, the branch that the PR is using. Paste it on my device inside lib. And then we'll go find the sample code, which I think maybe the PR added. Take a look at the files changed. So Cartesian, examples, DisplayIOLayout, Cartesian dev, DisplayIOLayout, Cartesian line plot. Okay, so that's what we'll use to test it. I think line plot is what we're looking at mostly. Not sure what the difference is, or if we need both of these. I wonder, these might just be two versions of the same script. I noticed this one has the print, and this also says line plot, but it's in the dev py file. I'm thinking maybe one of these is just left over, but we'll check on them locally and see if there's actually a difference. I'll take line plot first. Actually, I'm just going to open this up and grab the code. Back to my device, looking CodePy. So right now I have a wrapping test. This is from display text library. It's wrapping this long string into make it not go as long, right? Not be as wide. Essentially, it's wrapping it to either a certain number of pixels or a certain number of characters. But this is just an example from display text. We don't actually need to keep it. So I'm just going to erase it and put in my line plot. Take a quick look through here. So some parts mention that it maybe is made for the PyBadge display, but we're bigger than the PyBadge, so we should still be all right, I think. Make a group, make some data points, update line. Okay, it's all looking pretty straightforward. So let's do this. Let's put that over there. I'm going to save CodePy. It's going to run. Okay, and there we see our lines getting drawn. Nice. So far that seems pretty good. I don't see any real issues with that. That's pretty much the end of the test loop. It has while true so that we continue to see it on the screen. Otherwise, like if we didn't have this, it would just go away. That's looking good. So let's take a look at dev. Is there anything different in this? Oh, it has update line and update pointer both. Okay, so let's try running this one. Also, the sleep is a little bit different here. It was 1 second on this one, yeah. We'll put this one in. Let's see what this does. It's going to do a point. So basically there's a point at the beginning of the line each time. And it's also different data. Oh, interesting. Okay, they have some that do, this one should make an error because it's out of range. Yeah. Nice. Okay, that's working right. We'll leave that. It's testing. Well, I don't, for as a test, like a unit test or something, this is good. I don't know if we do want it in the example. Maybe it's okay to leave it there. This one also has different colors, I noticed on the axes. So I think we have a Cartesian simple test. Yeah. Basically just has update pointer. This is the one that we had previously. Makes the Cartesian and it makes the point. And then it essentially just counts up. Okay. Yeah, I don't necessarily think we need both of these. I think we could probably just have line plot as the new one. And then we can get rid of the dev one, I think. It's got a bigger range. Essentially, we give it just 2 points for the line, and it draws that line for us. So you could derive these points from, you know, a sensor or any other kind of data source, really. It's pretty straightforward, just update line. So the test seems pretty good. I don't really see any issues functionality-wise. Switch back to line plot for now. Hey, Dexter. You know, this shows that it can go back down as well. This one here went back down. You probably want to always have increasing X, but then, you know, Y could decrease or increase. So probably X you would want to be like, you know, time or something. It's always going to increase. Watching the batteries go flat. It would be cool to hook this up to like the LC, what is it? LC7 something something. I don't know the name of it, but the little fuel gauge device. That might be kind of a cool thing to plot the chart for. OLED. Nice. Made a battery charge monitor with an M0 Express and an OLED. Oh, wow. With an M0. Usually M0s are tough to do display stuff on, but if it's just like, if you're doing like one thing, you can usually get away with it as long as it's not too big of a display. That's cool that that ended up working if you got a charge monitor and then the screen to show it on with an M0. That's pretty cool. Let's put that back. So I'm thinking this is looking pretty good as far as the tests go. Let's just take a look in the actual code here. Oh, we do have a verbose. This is when you initialize the Cartesian, I think. So let's test that out. Let's turn verbose on. Verbose true. Save that. Now it should print some more stuff. I'm not actually seeing anything else get printed. This is not responding. So I had this happening yesterday. Did I do save? Sometimes I think I accidentally do Control S in here, and I think that wrecks things. I'm starting to... Yeah. Starting to suspect that sometimes I accidentally do Control S down here when I mean to do it up here to save my file, and I don't know what Control S does in a terminal, but it's breaking this. It's stopping this from updating for some reason. I seem to be... No? Oh? Are we back? I guess we're back, right? We see it on the screen. There we go. Okay, this is our verbose output. I need to figure out if that's like coming from PyCharm or coming from TO or coming from my terminal shell. Yeah, those are probably the three places. If I could figure out which one it's coming from and make it not do that, that would be fantastic. TO shortcuts. I know TO uses like control stuff. Control. Show. Oh no, this is Control T and then S. Okay, these are all Control T. So it's probably not coming from TO. It will remain a mystery for now. Nice. Two rectangles. Make like a progress bar type thing, basically. Set back here. All right, so in terms of changes, we have a new docstring because we have a new argument. That makes sense. Verbose is Boolean. It defaults to false. Sets it to a local, you know, field, I guess this is maybe on the object. I'm not sure if that's the right term, but because UpdateLine is true and we got rid of that. Subticks. Oh, okay, so this is fixing, this looks like it's fixing a little bug as well. It looks like, if this turned out negative, or less than 1, even if it turned out 0 somehow, although I don't, you divide something by 2 and get 0? I don't think so, but maybe. Maybe with rounding, I guess, to it, is doing the double divide, so it would round to an int. Anyway, if this turns out less than 1, previously it would have still just passed it to rectangle helper, which I guess probably would have drawn a line, like drawn no line, or maybe drawn a negative size line, like it goes up instead of down. I'm not sure what it would have actually done, but this fix now is making it so if this comes out to less than 1, it's going to default back to 1 anyway, because 1 will then be bigger and max will take that. So I don't know the full ramifications of what it did in the past, but I do understand this fixing it from being allowed to be less than 1, basically. We have a new little helper function here, calculate local xy. Looks like this is taking xy as an int and then returning pixels. Scales on plus self height -1. Oh, this down here. Yeah, I'm not sure which way is which. Truthfully, I'm kind of like a guessing checker a lot of times when it comes to math. So I'd have to like punch some numbers into this and then see the results, and then I would be able to tell what it's doing a little more easily. But my guess is one of two things. Either this is taking XY in chart coordinates, like XY based on these values on the bottom and the side. It's taking a pair of those and then returning to you pixel coordinates, or the opposite. It's taking pixel coordinates and it's returning to you XY coordinates based on the values on the chart. I think this is doing one of those two. I think I lean towards it's probably returning pixel coordinates. And it has a leading underscore, so it is not meant to be used externally. It's probably just used in the update line. Check local x is in range, takes a local x, returns true if it's within the Cartesian. Same thing for y here. X, y in range. Okay, helper function. This is just going to call both of these. Okay, local. So this gives us a hint. Local x is referring to pixels. Well, self.width would be in pixels. So it's essentially referring to like local. It is pixels, but it's localized to the Cartesian. So like no matter where it's at on the screen, I don't know if 0, 0 is down here, I guess probably. And it is counting pixels from there, I think. So then this would be the opposite, not looking at pixels, but instead looking at, you know, values, number values in the Cartesian. So we have one of those for x, one for y, and then we also have the helper that calls them both. Add point. This is a new function that we have, add point. Add a point to the graph. So I think previously we used to have only update point, I want to say. Take a look real quick. The current version. Pointers, update pointer. Okay, looks like we did have an update line function. Maybe it wasn't working right, or it wasn't allowing you to do multiple lines or something. Yeah, that plotter line. It does seem like it was only a single line in the past. And then draw pointers and update pointer. Again, this update pointer sounds like it's going to change where the pointer is at, but not necessarily allow you to add a new one, where this new one here in the PR is allowing you to just add more and more points. So theoretically, we could do, although this is private, Here's update pointer. Update pointer is now calling add point. And then draw pointers. Here's update line. This is where the bulk of the change is. Let's add point as well. And the actual line gets drawn with draw line. So can we make add point public? Do we need it to be private? I mean, like leading underscore basically, which is not enforced anyway, right? Python doesn't care. It will let you call it, but I'm wondering if there is a reason we don't want it to just be public. Let's put this code back on. This is the simple test. What if we change this to add point? Doesn't do anything. Interesting. Update pointer? Is it add pointer? Maybe it was add pointer. So this one draws the dot and then moves it. Just add point in the plane. So ultimately, does this as long as the point is in range. If plotline point is none, make it a list. Then append the values we passed in. Or not the values we passed in, but the local ones converted. Okay, so it adds it to this list, but it doesn't draw it. Just adding it to the list. Update pointer here. Update pointer takes an XY. It calls add point. If not self pointer, draw pointers. Outline point. So I'm not sure I understand why we have add point and update point, or update pointer. update pointer calls add point and then calls draw pointers, but only if self.pointer was not true. Otherwise, it just changes the XY of pointer. So I think we should add a point, helper function to add a point to the graph. This adds it to what? This is adding it to point. This is adding it to plotline point, which is a list. This gets appended. But then when we call draw pointers, this is getting the X value for it. Again, the last point in the list, this is getting the Y value for it. I assume it's XY. Maybe it's YX, but definitely the last point. So I'm not sure I understand why we have a list if we're only ever drawing one point. And the add point, the name, and the docstring here suggests that you could use it to add a point to the graph. But it seems to me like we're adding points to this list, but then we're only ever drawing the last one. So it's adding them to the list, but it's not really adding them to the graph. So I think we should either change that name add point, or else we should try to make it to where you can add multiple points to it. This is UpdateLine. UpdateLine takes the XY, calls add point, as long as we have more than one point, then we draw a line from the second to last point to the last point. So basically the one before we appended, and then the one that we appended, we draw a line between those two. So updating the line is why we have a list. Plotline point is a list. Add point is continually adding to it. And then update line is always using the last two to draw the line. So if you were to add more to it, basically you're affecting where the line's going to get drawn from, because it's always adding the point where it's going to get drawn to, which is this one. Okay. So I have a little bit of feedback. I don't think we need both of these. Okay. We're gonna do a review. Other thing I'm interested in. So update line adds a new line. Every time you call update line, you're gonna get a new line. But the name kind of suggests that it would like change where the previous line is at. So I think we should call it add line or draw line. Yeah, because it's never erasing the old lines. Whereas update point, like in the simple test, update point changes the location of the point. The point goes away from where it used to be. This one, update pointer, update pointer. With this one, it is changing the location of the pointer. The pointer was at one spot, and now after we update it, it goes to a new spot, and it's no longer at the first spot anymore. This one's always changing the point, not adding new points. I think we should call update line either add line or draw line. Name this to. Wanted to watch yesterday recording, as I have at least two stuff from EPROM. Yeah, 5416. I did. I mean, I think I did. I will say I am not 100% certain that I did everything correctly. Oh, interesting. I think I have one of these too, but I didn't realize this was based on EPROM. So yeah, this one I would say I'm less confident in. I have no idea if what I wrote yesterday applies to this device or not. I have not tried it at all. So that's definitely a kind of a try at your own risk type thing. The other one, though, that you linked, 5416, I think it was 5416. This is exactly what we worked with last night. And I do think it seems like I was successful. I can write bytes to it. I can read bytes from it. It seems like the bytes that I read are correct. So I think I was successful, but I've never actually used EPROM before doing that yesterday. Here, I'll drop a link with what I came up with yesterday. And I did test it on this 24LC32, this one here. And it seemed like it was working all right. As an EPROM, but maybe not the only feature. Yeah, no, I would definitely just try to watch one at a time for sure. That's interesting, though. I am curious about the NFC one. You know, I got one of these as well. And I didn't realize it didn't have a CircuitPython driver yet when I got it. And at one point I looked into trying to make a driver for this, and it seemed more complicated. But if it's possible, I would like to do that at some point as well, because I do think this thing would be really cool to use from CircuitPython too. And if it has a similar interface to the EPROM chip, then it might just work. Well, it probably has a different I2C address, so you might have to change that. But it might just work, or maybe if it doesn't work like right out of the box, maybe it's not requiring too much changes. That'd be really cool. Oh, there's EPROM in the Seesaw too. I think is that the Seesaw I have? I have an older Seesaw. I know there's... Yeah, I do. I think this is the Seesaw I have. There's a newer one with stemma ports on it. But I think I got one of these. I did no testing on this either, though. But that would be cool if the EPROM does work the same way. I'm guessing they all work pretty similarly. Yeah, this one says here, EPROM with 64 bytes of NVM. So it is only 64 bytes. One thing is the library we made last night, we had to hard code the size, and it was bigger than 64 bytes. So that would be one thing to watch out for. Is you would need to update the max size, or else like make sure not to go over the end. I don't actually know what happens if you go over the end though. Maybe it's no big deal, or maybe it causes trouble. I'm not sure. I think we should rename this to, I kind of like DrawLine better. DrawLine or AddLine. Was concerned with your 50-byte EPROM, but I saw that you figured that out later. Yeah, I did eventually. I don't know, I did the math early on and decided 32 for some reason. I think I divided a couple of things out, but I must have done something wrong when I did that math. And then looking at it more later, I realized it's, at least I think, it's 4,096 bytes total. And we got that updated to 1,000 in hex. And I did also test writing and reading to and from the last byte. So byte, 4095, we wrote to that and we read from it successfully. So I do think we have at least that much space. And I think that's the exact amount of space we have, but again, I don't have much experience. It's possible. Maybe we have more and I'm misunderstanding something else again. But yeah, it did seem like at first I was like 32 kind of sounded right when we started, but then once we got into it, it was like, that's not very much. Although the Seesaw is much closer to that, 64 bytes only, so double. Looks like this was previously existing, but maybe didn't function as expected in the past. With the new behavior, it now adds a new line each time you call it. new line to the graph. The update pointer method function changes the location of the pointer, i.e. removes it from where it used to be and adds it in the new location so that it changes location. New behavior now, it adds a new line to the graph each time you call it, rather than moving the previously created line. So with the current name UpdateLine, there seems to be different behavior between UpdateLine and update pointer, even though they have the same prefix in their name. We should either match the behavior or choose a different name for update line. I would lean towards the latter because I think it's cool to be able to add multiple lines to the chart. Maybe at some point we could even make it possible to add multiple points to the chart as well with a draw point or add point function. Okay, and I guess I'm probably okay with leaving add point. Like in my brain, it seems like add point would add a new point to the graph, which is, I kind of assume what users would expect it to do and kind of what it makes it seem like it will do. But it is private, right? The leading underscore means that, you know, outside code is not really meant to call it. So like I think it's probably doesn't get listed in read the docs and stuff like that. I'm not 100% sure. It does have a doc string, so maybe it does. But I'm like inclined to say that that's kind of okay, because I get the name add point. It is adding it to the list, so it's not like, you know, wholesale just not doing it at all. It is adding a thing to the list. So like I do understand the name. And because it's private, I think it's less likely that somebody would find it and get confused by it. So if we eventually add a new add point or draw point, then, you know, maybe it's at that point it's time to think about renaming it, or it may not matter since it would be a public one, but okay. Yeah, I think that's it, really. Honestly, with those two things, I'd probably be willing to call this good. If we just got rid of the dev file, if we want to, we could move the things that are different from it over to the line plot file, and then just renaming update line. I think that's the main feedback that I have, and I feel like it's probably good after that. We tested verbose, we tested the line drawing, we tested the old simple test, which still works the same way, which is good. We tested the new tests. Everything seemed to work fine on those. verbose got added and it's in the doc string, so we're good there. Yeah, I think those are kind of the two things, and then I pretty much think it's good after that. It's at S-Lite, I think, right? S-Lite. Yeah. Beta, what are we on? 3? I think this said this was a dirty build on my. Must have tested something in the core. This is a dirty build. Beta 3. Sure what the last thing I tested was. Okay. Changes, submit review. Perfect. There are 2 changes. Okay. So that's the first PR I want to look at. The other one is DisplayIO. Maker Melissa has added update the API to CircuitPython 7 and add typing to everything. So this has got a bunch of the typing stuff in it, and it also updates to match CircuitPython 7 DisplayIO API. I assume things like on this bitmap allowing an open, allowing a file name instead of an open file, and then it opens it itself internally. We're gonna go open this, Blinka DisplayIO. We can use this window, we don't need to keep layout. We're gonna go here, we're gonna go GHPR list. We're gonna go GHPR checkout 75. Add typing. Okay, and so we'll run some tests real quick. The easiest thing I have to test this out with is my Pygame display library. Blinka DisplayIO Pygame. We'll want to test it on a Pi as well, Raspberry Pi, because that's like the environment it's really meant to work in. The Pygame display thing is a thing that I added separately, and it's not like the primary, intended thing to support really. The Raspberry Pi on, like SPI displays is the like actual target environment for Blinka DisplayIO. I just figured out this way to use it on desktops, basically. So I guess we probably have Blinka DisplayIO installed. So what I'll do is I'll uninstall it. Okay, and now these should not run. Like if I run this, it should fail. So it can't import DisplayIO, which is actually coming from Blinka DisplayIO. So now we can go here, we can go pip install dot for this directory. This will install the version that is from the PR. Now we can go to here, and we can run this. Yeah. That part doesn't work. I feel like I've run into this before. I've run into this before. So I think let's uninstall this again. And then let's install it from PyPy. Got 070. What did we uninstall the first time? Oh wow, really old. 032. Can we run this with this one? We can. It works all right. So that's one thing that I want to comment on the PR is that ideally I want it to keep working for the desktop environment. Again, even though it's not the like primary target environment, I do think it's cool, and I use it for iterating, for testing DisplayIO stuff a lot. So I would love it if we could keep it compatible with that. So let's go back to here. Let's uninstall it again. Then install it from the PR again. See where it crashed. We import DisplayIO. This tries to import 4-wire. Let's look in the changes as well. Maybe we can spot actual change. Oh, interesting. Must have made an underscore typing. I've seen that for CPython stuff. Writable buffer and a readable buffer. So we used to, in DisplayIO init, we used to just from all these things import the individual thing. And now we go typing first. And then these are all dot underscore. But they do seem to be pretty much the same list otherwise. Actually, color space, this is new. I have no color space here. The rest of them look like the same. As you see display. And ultimately this is coming from the 4-wire one. Inside 4-wire, it's importing microcontroller. Inside microcontroller, it's raising the exception. Basically, a bunch of these got renamed to the underscores, right? Like if we look at the current one, these, yeah, they don't have underscores. Interesting. I wonder why Melissa decided to change them. The underscores. Does it say anything in the? It's typing to everything. Maybe it's a pilot thing. I'm curious why it didn't fail before, right? Because this would have been trying to import 4-wire. Oh, 4-wire in the current version only has time and digital I/O. Doesn't have microcontroller. And the new one must have microcontroller. Does. but it's probably used for pin, right? She added typing. There's probably some things that are type microcontroller pin. Okay, okay. Find microcontroller. So we have 3 usages here. All 3 are typings for pin, and then the import is the 4th one. We only have 4 total here. So those are just used for typing. So we should be able to just try except, is it import error? What kind of error is it? Not implemented. Oh, not implemented error. I think we have this in a few other places because I've found similar things before with Blinka DisplayIO. Pass, which is pass. Because it doesn't actually need microcontroller to function. It just needs it for the typing. Which the IDE could get this from stubs, basically. It doesn't actually need to have microcontroller as a usable module. So the IDE can still do all the typing stuff. But this should allow it to run as well. So if we go uninstall, yes, install from dot. Now we can run this, or at least get farther. Ooh. Types don't work. Interesting. That I'm surprised by. Usually, like on CircuitPython at least, if you're missing the import for something that you're only using for a type, it still runs fine. But CPython must not be able to do that. So this cannot be our solution then. We need to make it to where we just can import microcontroller. Which comes from Blinka proper, not Blinka DisplayIO. Probably. I can't scroll up. So let's put this back how it was. Uninstall again, reinstall again. Run this. Site packages. Microcontroller. Doesn't actually tell us, but I assume this is coming from Blinka. So microcontroller init line 141. I wonder. I wonder if Melissa's opposed to not raising an error here and instead just printing this. So like the code will try to go on. If you're not using it for anything that's not supported, then it won't crash. But you'll get a printout that says like, hey, technically what you're doing is not really meant to be supported. So like, you know, you're kind of on your own if it's not working. Because I think if we did like, well, let's update this. Git remote v git fetch Adafruit. Let's go to main. Update. Check out. Okay. So if we printed this, print. What happens if you print with a comma? Print hi, hello. There. Prints both with a space. Perfect. So if we did that, and then install this name. Is it really capitals? Interesting. Blinka DisplayIO I think was lowercase, but Blinka is capitals. Pip uninstall Blinka. Yes. Pip install dot. Okay. Yeah, no, it runs fine. And it, you know, it does still print this. Maybe we could add like warning. Here's where it printed here. Or the other thing it could do is check out -b allow unsupported from Adafruit main no track. Gonna make a commit with this. Print warning instead of raise error. I don't really need to push it, truthfully. I just want the commit locally. And then I'm gonna go back to main. So this is back to raising. Uninstall. Reinstall. So back to here, this will crash. So the other thing we could do is in here, we could say try except not implemented error. microcontroller equals basically we would want like whatever's in the stubs for microcontroller. Class pin. I don't know, we can't just like define it in line though, can we? Does this work? Oh. We could do from import pin. And then here we could do pin. So if we do import it, it will come from microcontroller. If we don't import it, we get the stub. I think this will work too. No. Oh, well, because it has the same problem in display. Yeah. So, I mean, it probably has the same problem in a bunch of them, right? Oh, let me catch up the chat here. Live report. Found the old seesaw and the new seesaw. New one also has EPROM with 127 bytes. Got double the number of bytes. Oh, that's interesting. It gets its I2C address from the EPROM, so you can change it to like whatever you want. That's really cool. So this would have to change everywhere, right? We'd have to add this stub like everywhere, which I don't think we probably want to do. Grep -n import micro. We need a space, right? Import microcontroller. So there's only 3, I guess. Display, parallel display, e-paper display. Yeah. Let's think this through. We could make like mock microcontroller. We could give it class pin, and then inside of the catch, we could import from that, and we could do it in 4-wire, and we could do it in display, and we could do it in parallel. Wait, where did that come from? Parallel display? Oh, it's in the root. But then we're basically just maintaining an extra copy of the stubbed pin class inside Blinka DisplayIO for the purposes of running in unsupported environments, basically. Which doesn't seem great, because then, like, if we change this stub in the core, it's not going to automatically update over here. So then they could get out of sync. I think that I like the... Like, this would solve it. It would allow it to run also, if we did this in all the places we need. But honestly, I think the... Did we change? Oh, right. Save. Okay, back to normal. I think the fix here is better. I don't know if Melissa will be on board with not raising and instead just printing. But I feel like that's the simplest solution that allows it to work and doesn't mean that we have to like duplicate the microcontroller pin class stub. It allows the typing still to work. I kind of think that's the best solution. So I am going to go ahead and push this. foamyguy allow unsupported. It's the only change I made. Whoops. Project to allow it to continue. Let's say allow it to try to continue even on unsupported environments, i.e. print error, print warning instead of raise exception here. Whoa. Guys screenshotted? What that was. This doesn't one box, which is a bummer. I was hoping it would. here inside of microcontroller init. Okay. Gonna get this error again. So the newly added import microcontroller statements which are used for typing info. I feel like we have where it would be. Git grep not implemented. Oop. Oh jeez. Oh jeez. I feel like I've done this before somewhere where I caught this error in order to allow it to go on. I don't know where it was. Git grep and not implemented. They're all raising. Except. I don't think this is where it was at. So I'm not sure where it was at. Maybe it's not. Maybe it got removed at some point and is no longer necessary. I don't know. Or maybe I'm just misremembering and I didn't actually do this. What would it take to support generic x86? Well, I mean, the true answer is I don't know for sure. I think the main hurdle to that is that most Linux environments, like just generic x86 environment, doesn't have like I/O pins that you can access easily, usually, right? Like there's not really going to be a SPI bus, an I2C bus, and pins that you could set up as digital in out on like your average laptop or desktop thing. And since Blinka is meant to run on like Raspberry Pi type form factors, where there are I/O pins and there is a SPI bus and an I2C bus and all those things, like the vast majority of what Blinka is meant for won't work on a laptop that doesn't actually have those pins to allow you to do that. And if you did have a laptop or a desktop that does have those pins, probably the best thing to do would like add a chip ID for it and then add it to this list as a supported device. If there is like a specific one that does have all the hardware you need in order to actually be able to do that. Yeah, I mean, that's possible to pass, but I think, I mean, ultimately it's going to be a question for Melissa is like why it was raising, but my suspicion is like almost nothing from Blinka will work on a generic x86. So my guess is it raised in order to be like, hey, you're trying to use this library and like basically, 5% of it is going to work and that's it, if that even. It just so happens that some small portion of it that does work is Blinka DisplayIO in this other context here with the Pygame display that I created. So it's like its own little weird side case, which is meant to run on Linux, like desktops and laptops. And I guess maybe Mac and Windows as well. I haven't tried it, but it might work on those environments as well. But I think Blinka, by and large, doesn't support generic x86 because the vast majority of the stuff you could do with it just won't work. So I think it would make it confusing, like, essentially people would not necessarily understand what Blinka is for. They might find it, they might, install it with pip on their computer, and then be like, hey, why is this not allowing me to, like, turn on and off this LED, for instance? And the answer is because like your computer probably doesn't have I/O pins. It just can't work. It's not the same as a Raspberry Pi with those pins. It could be possible. There's computers out there that expose those, but I think in that case, probably the best thing would be to like add it to this big list. I mean, what you put there, I do think would work. Like we can have that exception here, and it could just pass, and that would also solve the problem. And I would say that I'm open to that, but I don't know if Melissa will be open to that. I don't know necessarily if she'll be open to this either. I think this is probably the safer bet, though, because if it gets to here, it at least like prints a thing. And we could put this print inside of your elif there, too. So we could change the, it could be an elif, and it could check generic x86, and it could print this here, and then it could still raise for others. That I think would be fine as well, but I do think we should print like this, because at a bare minimum, I think we should warn people like, you're importing this thing, and like we're gonna trust that you know what you're doing. We're not gonna crash right now, but like, it's not really supported, and it probably is not going to be able to be used for very much unless you're like trying this one hyper specific use case. What if you're running it with the MCP 22.1? What is that? That's like the serial converter thingy, right? Yeah. Okay, so this plugs into USB and then basically does give your laptop those I/O pins like I was just talking about, and buses. It looks like it gives it an I2C bus, which you can then access. I don't know. Let's look at how it works. I suspect it should work today already, honestly. I don't know how it works, though. Let's see. This does show Blinka. So let's read through this. How does this work? Question about yesterday. Library file is, yeah, that should be changed. It should have 24LC32 in the example name. I just named it the wrong thing, or didn't update it after the fact or something. It's a good question, David. Thank you. Additional information. HID API. Install on Windows. Install Python 3. Install this HID API. Install Visual Studio? Oh, if you get this error about build tools, then install Visual Studio, because it allows you to get the build tools. Install Blinka. Huh. What is this? Maybe this is why it's working? This is a good question, Dexter. Thank you for asking, because I do... With that device, it does give your laptop I/O pins, and it does make a lot more sense to support generic x86 in that case for sure. My guess is there's some like case built out for it that's allowing it to work today. There's also generic Linux here. So, I wonder... This doesn't find MCP at all. Huh. Yeah, I don't know. If you're using this device, I wonder where you fall in this if statement. Hmm. I do think you could use Pygame display together in conjunction with the MCP. I think Dexter's question is basically like inside of Blinka, where I changed this from raising an exception to printing a warning. I think Dexter is asking, would it be better to make an elif like this, chip ID equals, and then I don't know what this AP chip is, but basically, yeah, I mean, I don't think AP chip will work. It's on here, we'll have to go add it. Pass. So basically, instead of just printing the warning, we're actually adding a case for generic x86. I mean, the other issue that you have is like my computer reports this generic x86. I have no idea though if that's like all computers or like Windows or Mac. What is AP chip? It does seem like this exists. Yeah, it does. Interesting. Let's see if this works. Smart checkout. This is back to raise. I'm going to make a new branch, get checkout, the generic x86. Nope. Adafruit main. No track. You have to have the breakout board installed. You can't trick Blinka into using a board that's not installed. There is the FT223, this one. There is this one. There is not. There is not MCP anything in this file. But there is stuff in Blinka for it in here. So I don't know where. I'm not sure why it's not in this file, but it does exist over here as part of the Blinka project for the MCP one. So if this just passed, yeah, no track, do that. Okay, so now uninstall. Install. To your question before though, Dexter, I do think you could use the MCP with the Pygame display stuff. I don't think there would be any problem using both of those things together. So like you could, you know, read a sensor from the MCP device and then plot the results of that sensor into, you know, Cartesian or whatever else you want inside the Pygame DisplayIO window. I do think you could do that, which would be pretty cool. Should make an example that does that. Okay, we installed this. So does this run now? Does. Okay. Maybe this should still do print warning. Generic x86 is not fully supported. Some features may not work. Maybe we should still print this. I'm starting to like this better than changing the raise. The one thing that I do think though is we need to find out if generic x86 is the same thing that gets returned on like Windows and Mac. On a default environment like standard Windows, standard Mac, as long as that's the same thing, then this will work on all three. If it's not the same on Windows and Mac though, then we would want to add those two, I think, whatever they are. Because I do want Pygame display. Theoretically, this should work on Mac and Windows the same. I've never tested it. I want to say somebody tested on Mac at one point, maybe K-Match, I'm not sure. I want to say somebody tested it, and it should work on Windows as well. But again, I haven't tried it. So we should try to keep it working on all three if it can. So this time it did print it, this thing. But I think it's probably good. It makes sense to print that, because I do think we want to warn people, like, hey, you know, it kind of works for this, but it really was never meant to. So, like, you're kind of on your own. Like, if there's a lot of stuff that doesn't work, like, that's kind of expected, you know. If you're using the one, like, hyper-specific thing that it's built to do that does work on PCs, then, you know, it'll work and it'll do what it'll do. And if it doesn't work, you can find me, because I made that thing, and you can ask me why it's not working. I'm happy to help out, but you know, if it's a person like trying to use digital I/O just from their laptop or something without like that MCP or anything like that, then I think we should be warning them like this is not going to work and it's not supported. So it's not necessarily like anyone's going to help you make it work. The easiest thing you could do is go get one of those MCP or the FT whatever 22.3 something. You could get one of those and then you could do it. But if you're trying to do it without that, then you're kind of like on your own a bit. So let's do this. Let's also take this. Let's put this here. Or another potential solution. Add another branch to the if statement to allow generic x86 simply pass. Further. Tested both of these possible solutions with the Pygame display Blinka library next PC, and both do allow it to run possibly. It's worth printing the warning in either case because the vast majority of functionality Blinka provides is not intended to work in that environment, but DisplayIO specifically can because of the Pygame display library. Windows, the chip ID is none. Yikes. Yeah, so then we'd have to have like elif chip ID equals none, which basically would defeat the purpose of raising. Well, that's not true. There could still be other devices where it returns a value that's not none, that's also not in this list. I've done all of my testing on Linux, but ideally it would be great if we can allow it to import successfully on Windows and Mac also. Well, that's already mentioned, I guess, right? So none, that does make it tough. I guess Mac probably is more likely to behave like Linux. Windows being none, though. I mean, we could always add, like, maybe platform detect could be updated to detect Windows and actually have a value for it. Maybe that's a possibility. Hey Johnny, how's it going? Okay. Late to the party? Yeah, we've been running for a little bit. Done a couple PR reviews today. Really good for a first comment. Let's do this. I'm also going to go through and look at the code as well. Like, I tested this out and we have all this feedback, but I think I'll just take a peek through the code as well and see if there's anything in there I want to mention, or if it's all looking good. Release displays returns none, which is fine. Height and width are ints. Value count is an int. That all makes sense. Get item could be either a tuple of ints or a single int, and it returns an int because this is on what? Bitmap. That makes sense. We get an int, which is an index basically. An index into the palette. Oh, swapping it over to f strings here. I need to get f strings drilled in my mind more. I still default to format instead of f strings. I just forget that it's possible. Set item. So this takes an index, which is again either a tuple of ints or a single int, and a value, which is a single int, returns none because it's a setter. Fill value is an int, returns none. That makes sense. Blit. We have a new blit function inside of bitmap. 30. Blit. We have blit in DisplayIOLayout docs. CircuitPython. We have a blit on bitmap. I know we have in bitmap tools. Is there one on bitmap too? There is. Okay. Interesting. I was thinking this was from bitmap tools. Okay. That's cool. That's one of the things where Melissa was talking about adding the, like updating the API to be CircuitPython 7. There is, yeah, there's f-string support in CircuitPython. I don't remember who it was, but somebody added it a while ago. Well, I mean, not that long ago, a couple of months or something maybe, but I think it's limited. I think it cannot do maybe all of the things that it can do on CPython. I'm not, again, I don't use it too much yet, so I'm not 100% familiar with all it can do, but I think maybe there's things it doesn't do in CircuitPython. But the most basic case of just like f at the beginning, insert your variables into the brackets, that part works. Yeah, it's pretty cool. We got blit, we got dirty, x1 int, y1 int, x2, y2 int, makes sense. None. Width returns an int, that makes sense. Height returns an int, that makes sense. Color space is a new thing. Type is color space. Dither is a boolean. Color is an int. Color is an int. Color is an int. Again. Again. This one returns an int. Again. And returns none. Again. And returns none. Dither is a boolean, same as before. Set it to a new boolean. New constants. Here's our new import that is one of the ones that made us crash. Okay, display bus is a display bus. Its sequence is a readable buffer. Int, color depth int, grayscale, boolean, int boolean, int, optional pin, optional int, and it's none, so optional makes sense. This one? Ah. We'll reply back to that later. We keep going through this. Oh, there's no F strings on the M0. I didn't know that. Yeah, that does make it a little weird. If you want to move your code around, then like you almost probably need to stick to format for now. I'm almost to the point though where I like really the only things I run on M0 still are like if someone is having a specific problem with a specific thing, and I'm gonna I'll grab an M0 to test it out, but I kind of am go to M4 or like RP2040s at this point are sometimes even cheaper than M0s, and it's a more powerful processor, so it doesn't change the fact that I have a couple M1s lying around, or M0s rather, lying around, so like it's a shame not to use them for anything, but got more RAM and stuff on the M4s at least. I tend to default to those. Float for brightness, boolean, boolean, int, makes sense, boolean, int, that looks good. Invalid name, exception. Okay, parallel bus moved from DisplayIO to parallel display, so a little bit of refactoring. This is one of the changes from CircuitPython 7. Pretty sure. Write got turned into send. I wasn't familiar with that one. It makes sense if that changed. There are no types here. Not a huge deal. Or here. Or return here. Group returns none. Optional int returns a boolean. What is this? Refresh? Oh, I think it returns true if it refreshed or false if not. Loop. Okay, write turned into send. This makes sense from above. I understand this all the way, but it does work, right? We did run the test and it did work, so. Okay, using max instead of if statements here is nice. Makes the code more concise. Max and min. There's also no types here, but again, like, I don't know that we're necessarily aiming for 100% completion at this point. Like, we haven't enabled it in pre-commit or anything to check for it, so like, it's not a big deal if, like, you know, obviously Melissa's added a bunch of type information. I think it's okay if it's not 100% all the way of everything. At some point we'll add it to pre-commit and then we'll fill in what's left, but this is a huge step forward even if it's not 100%. Auto refresh returns a boolean, gets set to a boolean. Brightness is float, we saw that before. Brightness gets set to a float, makes sense. Auto brightness is boolean again, updated to a boolean again. Width, height, ints, makes sense. Rotation, yeah, that's an int. It's like 90 or 270 or 180. Rotation, or 0, I guess is the other one. Int. This returns a display bus. There's a new file. Has display bus, which is one of these. Paper display move to the underscore. Display bus, readable buffer, writable buffer. All these are ints. Height width, RAM width, call start, rotation. Looks good to me. Command, this is either int or none. All of these four. Int for RAM command. Black RAM command. Black bits inverted, Boolean, yep. Optional, none, or int. Boolean, int. This one says float, but it sets it to 40. Should this be int, or possibly the default value should be 40.0? Optional pin is none, Boolean, float, same thing for this. Boolean. Used argument, I don't know, we must not be flagging this pylon thing anymore. Parallel display moved, so that makes sense. Group returns none, refresh returns... Interesting, refresh in the other one returned true or false. What file is this? E-paper display. This returns none. E-paper. Yeah, returns none. Raises an exception. But what is display? I think it'd be nice if display and e-paper display refresh function behave the same, like both return a Boolean or both not return anything. But that's kind of like aside from the scope of this PR. Yeah, see, display it returns a Boolean. While display bus. Doesn't really say what it's going to return though. Oh, refreshes the display returning true. It's taken too long since the last refresh call. With a given frame rate, then it returns false immediately without updating the screen. To hopefully help getting caught up. So I guess we just don't have that problem with e-paper. Maybe that's why it is a different API. Time to refresh. Okay, this one did change to a float. So I do think those ones above should either be ints or should have the dot zeros. Oh, interesting. This didn't used to return? Like this didn't used to return. Huh. Wonder if that was a bug. It's not implemented yet, I guess. Returning height, which is an int, width, which is an int. Display bus. Okay, now we're into 4-wire. Spy bus is a bus IO spy. Pin. Is command actually a pin? 4-wire? IO 4-wire? 4-wire? Command, it is a pin. Data or command pin. Nitpicking a little bit, but I think this would be better to be called command pin, because command makes it seem like it would be an int or whatever we saw before. Actual command, you send the thing instead of the pin that is a command pin. But I also don't know exactly what a command pin means in this context, so maybe it makes more sense if you know that, which I don't. So microcontroller pin, int for baud rate, polarity, phase, all makes sense. Reset returns none. Data is a readable buffer. Toggle every byte is a boolean. It returns none. Yeah, see here command. Well, so we don't set command actually. We don't have a type for it. But here command looks like an int that's getting checked. Well, and actually this says. It's weird to have a different thing called command that's actually a pin when we have this thing called command and it's an int. They're in different places, so like, you know, it might make sense with the context, and I don't know that much about 4wire, so maybe the name makes sense, but it could be more clear maybe if they each had different names. So data type is int. Chip select would be a pin? No? Okay. That's another case where chip select sometimes is a pin, but this time it's an int. Data is a readable buffer. This got changed to private, basically, leading underscore. Doesn't have a return type, but again, I think it's fine to not be 100% of everything at this point. File grid, so all the imports changed basically. Max size is gone, which is one of the other things to update for CP7. Scale is an int, x, y are both ints, makes sense. Deprecated, removed. Removed. Makes sense, protected access because of the underscore. A couple of these, like there's no type information here or here. Looks like maybe the mostly just skip type information on the private ones, right? The leading underscore ones, I think, are largely the ones that are missing it still. Which kind of makes sense, right? They're not meant to be used by external stuff, so the types, like, you don't need to know them because you shouldn't be calling them. Append, this can take a group or a tile grid. Can also take a... I don't think we have vector IO. I think this can also take a vector IO in the core. But we don't have it in Blinka DisplayIO yet. I would love it if we could, though. Yeah. Like a vector IO object. Since we don't have it for Blinka yet, though, it makes sense. Int for index makes sense. Group or tile grid again makes sense. This returns a group or a tile grid. Makes sense. Pop, same thing. Remove returns none. Length is an int. Get item is a group or a tile grid. Set item returns none. Value here, this could have... So this could actually be... Could have index int. Sure. This is necessary for the built-in get item function, though. It's okay to leave it out. Could have index int and value this thing. Same thing here. I won't put it on every single one, though. I suspect this is kind of the same deal, right? This has leading underscore, which makes it not exactly private in this case, because it gets called with square brackets, or, well, this one is the delete operator. The other ones are the square brackets, get item, set item. It does have the return type though, which is none. So I am inclined, I guess, maybe to say index should probably have int also, but yeah, set it to this one. Should have index int. Key is a function, basically a callable. Reverse is a boolean, returns none. Hidden is boolean, gets set as a boolean. Scale is an int, gets set as an int. Internal setter also is an int. This one is private, but does have the type information. X returns an int, gets updated to an int. Y, same thing, same thing. This got moved to below the imports. Turns none. I guess it used to have returns none also anyway. Flaps the string though. Command is an int on this one. Data is a readable buffer. Returns none. Data type is an int. Chip select is an int. Data is a readable buffer. Makes sense. Returns none. This is another one. It actually had it before, but it just changed the string. This is on disk bitmap. Init takes either a string or a binary IO. So right now we support either passing the file name, path, really, the full path, or the open file. Eventually, I think the idea is we're going to settle on just the name, or the path, rather. But right now it supports both, so this makes sense. Width, again, int makes sense. Pixel shader, it could either be a palette or a color converter. Depends if you're using ePaper display. I think it gets a color converter, but if you're using regular display, it gets a palette. Get item. Makes sense. It could either be a tuple or a list or an int. Because you can do like 0, 0, or you can just do 0. It's basically like treating it like a 2-dimensional array or a 1-dimensional array. Turns an int. Makes sense. Wait. You can't. You can't get item on disk. These don't have, do these have the get item? Oh, they do. On disk bitmap. Well, okay. It's in palette. Get item. But on disk bitmap doesn't. Which makes sense, because you can't get the pixels of an on disk bitmap. They're not in memory. They go straight from the disk to the screen, and they don't stay in memory. Which is why it's an on disk bitmap instead of like image load bitmap. Interesting. I guess DisplayIO just did it anyway. And maybe DisplayIO, it can, because like we don't care about the memory, right? We have essentially infinite memory compared to a microcontroller. I mean, I guess it used to exist anyway, right? It's not like it just got added with this, so even if we want to remove it, it's probably not really part of this PR. Yeah, we could leave that off. I don't think we need that. Boy, that's scary. It's gonna only remove the one, hopefully, right? Alright, palette. Color count, int, makes sense. Length is an int. Index is an int. Value is either int or a readable buffer or a tuple. This one, can it really be a readable buffer? Should be either an int or a tuple, I think. Like it's either like 0x ffffff or like tuple, 255, 255. This readable buffer here. Can be bytes. Byte array. Interesting. I didn't know you could do bytes. Okay. Yeah, that's where the... I guess this one maybe. Byte array would be the readable buffer one, maybe. I guess that makes sense. Never knew you could do that. Okay, index, good. Either returns an int or none. Int returns none. Int returns none. Is transparent. We have now in the core. Okay, shape. All ints returns none, makes sense. Bitmap is either a bitmap or non-dis bitmap or a shape. Shape gets a tile grid. Pixel shader is either converter or palette, makes sense. Height, width, ints makes sense. Tile height and width are optional, so they could be none, but they're ints if you provide them. Default tile is an int because it's a tile index, makes sense. X, Y are both ints, yep. Okay, tile height has to and width have to be greater than 0. Makes sense. They transform. And have types here, but again, this one's a private one. Hidden returns a boolean. Gets set as a boolean. X int. Y int. Flip x is a boolean. Flip x is set as a boolean. Y is a boolean. Y is a boolean. Transpose xy, that's a boolean. It's set as a boolean. Pixel shader, color converter palette, yep. Get item, again, this one could take a tuple with 2 ints, xy, or a single int, treating it as a one-dimensional array. Returns an int, makes sense. Same thing for setting, right? Value has to be an int. Index is the same here. It can be a tuple or a single int, returns none. Changing up the imports, this was all just refactoring a little bit. Pin, pin, pin. And are these really all pins? Parallel bus, I guess so. Not very familiar with parallel. I'm pretty sure it does use a lot of pins though. It's like 8 pins at least, maybe. Parallel bus. Inferred from data 0 by implying the next 7 additional pins. Okay, reset returns none. Send, command is an int. Data is a readable buffer, returns none. This is in CircuitPy. And the only reason this changed is because of the refactoring, right? Parallel display used to be in DisplayIO module or package. I don't know the right term, but it used to be inside DisplayIO, the folder. Now it's on its own in a file, and now we have typing also on its own. Yeah, the rest of this stuff looks pretty good to me. All right. All right, so that was a big review because there's a lot of code because this is like, you know, everything that's in DisplayIO, right? So took a minute, but we made it through. Cool. All right, I'm excited about this. I'm a big, you know, obviously if for folks that haven't seen the stream a bunch, I'm always working on DisplayIO stuff. It's one of the things that I'm drawn to most in CircuitPython. So, and Blinka DisplayIO is really cool as well because of the way that it can run on Linux. Without Blinka DisplayIO, the Pygame display thing wouldn't work, and I really think the Pygame display is super nice for testing DisplayIO stuff more quickly. Like I can iterate through a user interface when I'm building it, and I can do it all on the PC. And then once I have it looking how I want, I can then take it over to the PyPortal or whatever device I'm using, and just have to swap like a couple lines of code where it initializes the display, and it's good to go. And I really like that ability to iterate the interface without using the actual device. It seems counterproductive in some ways, right? Like the whole point is to run on the microcontroller, but being able to run on the PC means you can like try a bunch of things really quickly without having to dig out the right controller or have it connected or, you know, keep updating it and waiting for it to refresh and stuff. The iteration loop in CircuitPython is already fast, but keeping it all on the PC makes it even faster when you can just run it and see the results right away. Anyway, I think I'm probably gonna wrap up there. The other thing that I have in the works is I'll talk about it for a minute, but not gonna get to doing it on the stream today. But this busy simulator thing, this made the rounds this week on the internet. I think they showed it on Ask an Engineer or something at one point as well. Maybe they made a blog post. I don't know. Basically, it has all these different notifications, and you can click them to turn them on. I'm not going to click them because I don't want to hear them right now. But basically, you click these icons, and then it starts playing the notification for that program. So, you know, like all of these programs have their own little like jingle notification sound thing, basically, right? And then, vibrating phone, it just sounds like it's buzzing, like your phone on the desk or something. So we're going to put this into the PyPortal. We're going to make a grid with these same icons. We're going to show it on the PyPortal screen. You'll be able to click those icons and it will turn on that one of the jingles and it will play them as WAV files. It will play them out of the speaker. I have an external speaker connected up to my PyPortal here. And then I think it just plays on a loop. Like it just plays over and over again every few seconds. And then you can increase or decrease the speed with these little bars at the bottom here. I don't know if we'll pull that part over into the PyPortal the same way. We might change it up a bit to figure out how to control the speed. But basically the idea is like it plays these jingles on a loop, and then like, if you put this in the background, it would sound like you constantly have notifications going off. So it's kind of a little like joke project essentially, like you could play it in the background and somebody would be like, oh man, you must be really busy because you have lots of these jingles going off all the time. That's kind of the idea around it. And so yeah, I'll be making the PyPortal version of this basically. So we'll get a grid layout. We'll get some icon widgets, probably the same way we did on the touch deck. Throw them on the screen. We'll get some wave audio playback. Let it run in a loop. That's pretty much all there is to it. Put some nice clouds in the background, maybe. I'm curious if I can find actual wave files. Or MP3s. But they are here. We could just download these directly. Yeah. We could download this from here, convert it to a WAV file, and then we'll be able to play it in CircuitPython. Cool. But yeah, that's the next thing I'm working on. So I'll be doing that probably later on today, or I may work on it some tomorrow as well. And then once the app is done, then I'll be writing a guide up for it as well to show you how to get it on your PyPortal, how to use the external speaker, because you do have to, there's a little trace right here that you have to cut. Well, you don't have to, but you should. Basically, it cuts off the power to the built-in speaker, so that way you only have sound coming from either or, not both. So that'll be in the guide as well. But probably look for that guide like next week or maybe the week after. If you're interested in that kind of thing. But yeah, that's kind of what I got going on. I think I'm going to wrap it there for now. I got the 2 reviews done. The second one took a little bit of time because it's such a big review, but I'm stoked to see all of these changes in Blink DisplayIO to get it updated to CircuitPython 7 APIs and have typing as well. Typing has been kind of like my pet project a little bit, so I'm really excited to see that come into the Blink DisplayIO world as well. Melissa did a great job adding a ton of stuff to this, so great work. Probably got a hug report for Melissa this week. But yeah, thank you, Johnny, Dexter, David, anybody else who was watching. That was maybe the only folks, yeah, that came up in the chat. But thank you to anybody else who is watching as well. I will see you all. Let's see. Next week, I think, is Christmas Day. Yeah. So I probably will not stream next Saturday on Christmas Day. Christmas Eve on Friday night in the deep dive slot. I think I might. I don't think I have really anything going on Christmas Eve. So as long as that holds true, then the next time I'll stream will be the 24th in the evening, kind of in the deep dive slot. But next Saturday I'll be off. It's Christmas for lots of folks. I celebrate Christmas, so I'll be out with my parents and stuff. So yeah, I won't be streaming next Saturday, but maybe Friday, and then maybe this Friday as well, the 31st. New Year's Day, I'm not sure about. I don't think I have anything planned for New Year's Day, so I might be back at it then, but if not, then it'll be the 8th will be the next time. So not 100% sure, but tentatively Friday evening next week is my next stream, although it is like, Christmas Eve night, so I don't know. Folks might be busy, and that's totally fine as well. I may go shorter than normal, but we'll see how it goes. But that's the next time. Otherwise, like after we get past the holidays, you can always find me at the time that I streamed today, which was 10 a.m. Central Time on Saturdays. So that was about 2.5 hours ago. That's when I started today, and I generally start at that time every Saturday. So whatever time zone you're in, whatever time it was 2.5 hours ago, on Saturdays, that's usually when I stream. So you can catch me here in the Discord, in the live broadcast room. I'll always post links when I get going, and then of course on Twitch and YouTube. So yeah, thanks everybody. Hope everyone has a good weekend. Hope everybody has good holidays. If you're not in the meetings or anything, if we don't get a chance to chat or talk at all before then I wish everybody have good holidays. If you're celebrating the holidays, just have a good time. If not, that's totally cool as well. And yeah, I'll catch you next time. Thanks.